Hello everyone, let's start the question. Question says that a power transmission line feed input power at 2300 volt, a step down transformer and its primary winding having 4000 turns. The output power is delivered at 230 volt by the transformer. If the current in the primary of the transformer is 5 ampere, its efficiency is 90% and the output current would be. So in the question we have to find out the output current. Okay, so in the question the efficiency is given, so we can write efficiency that is neta equal to 90%, that is 0.9. okay, so we know that the neta is equal to the power output by power input. Okay, and for power we know that the formula is voltage into current. Okay, so for power output it will be voltage output into current output divided by the voltage input into current input. So we and the question has asked to find out the I output. Okay, so we don't need the extra information such that 4000 turn. Okay, we can use these parameters v0, vi and ii and solve this question. Okay, so in the question the v0 is given 230 volt and the vi is given 2300 volt and current input is given 5 ampere. So if we substitute the value here, the neta is 0.9 and this will be equal to the voltage output, that is 230 volt into the current output divided by the voltage input, that is 2300 volt into the current, that is 5 ampere, the input current. So here we see that this is cancelled out and it will be 10. So here we can write the current output equal to 0.9 into 10 into 5. So if we solve this we will get 45 ampere. Okay, so if we check the options, the correct option is 45 ampere. So we can write the correct answer is 45 ampere. Thank you.
Hello everyone, the question says that arrange the following electromagnetic radiation per quantum in order of increasing energy. A for blue light, option B yellow light, option C X-ray, option D radio wave. Now we know, so first we will write, we know energy of electromagnetic radiation E always equals to h nu, where nu is frequency, Now it is clear, E is directly proportional to nu is frequency. So we also know, so frequency of, so radio wave, microwave, so this is our electromagnetic spectrum, infrared, visible, ultraviolet, X-ray and gamma ray. So we know about this spectrum. So it has high wavelength and lowest frequency. Gamma have highest frequency. So now first we have given blue light. So blue light will lie in visible spectrum. So it will lie in visible spectrum. This is for blue light. After that yellow light and X-ray and radio wave. So radio wave has the lowest frequency. So it has the lowest frequency, hence its energy will be less. So now we have to find out the order in increasing order. So for increasing order, so first we will check which have the lowest frequency. So lowest frequency is radio wave. Now D will be first. After that radio wave we have given X-ray. So X-ray have highest frequency. So X-ray have highest frequency, hence C will be having more energy because it has the highest frequency now visible. So out of the yellow and blue, so we also know Vibgyor, red have lowest frequency. Red have lowest frequency. After that blue and yellow. So yellow will have lowest frequency as comparison to blue because it is the order of decreasing frequency. Hence yellow have lowest frequency than blue light. So this option will here B will come. After that here Y will come, sorry, have lowest frequency. So here, so yellow have lowest frequency, hence option B will come here because B stand for yellow light, and A and then C. So it will be our required order, that is D B A C, that is option D. Hence option D is right.
Hello students, we have a question. A conductor lies along z-axis. These are the coordinate points of the extreme points of the length of the conductor. This is the one point, this is another point. So its length is 3 meter and carries a fixed current of 10 ampere in negative of z direction. It means the current is moving downward, as we can see in the figure. For a field B is equal to 3 into 10 to the power minus 4 e to the power minus 0.2 x in positive y direction. The unit is Tesla. So we can see this is the magnetic field which is moving towards the positive y axis. Now find the power required to move the conductor at speed which is constant to x is equal to 2 meter, y is equal to 0 meter in time 5 into 10 to the power minus 3 seconds. Assume parallel motion along XA. So in this question we can see that power required is equal to work done by time taken. So we have the amount of work done to be f dot dx. This is to be integrated with the limits of positions and divided by t. Now if we talk about this force F, so we very well know when a conductive material moves, this is a conductive material, moves with some velocity in the presence of magnetic field. So we have the formula as F is equal to BIL sine theta, where theta is the angle between B and L. So in this situation we have sine 90 degree. So we directly write BIL dot dx, and this integration is to be done from the first position to the next position, that is from 0 in this direction, that is 2. So we have 0 to 2 limits and we have the time in division. So this is the basic equation we got for the power. So power is equal to, we will put the values 0 to 2 limit. B is given as 3 into 10 to the power minus 4 into E minus of 0.2 x, and the next value given to us is I, which is 10 ampere, and the next value given to us is length. The value of length, we can see that this is positive 1.5, this is negative 1.5, so the value of L is 3 meter. So we put the value 3. Now we are dividing this with the given time, and the time given to us is 5 into 10 to the power minus 3 seconds. So on solving, we are getting the value as 9 into 10 to the power minus 3 to be common, divided by 5 into 10 to the power minus 3 to be common, and on integrating the remaining term of 0 to 2 limit with an e to the power minus 0.2x dot dx. So we solve this. P is equal to 9 into 10 to the power minus 3 upon 5 into 10 to the power minus 3, and we are getting the value as e minus 0.2 x divided by whatever the constant is there with x. We introduce the limit is 0 to 2, so we have the value. So we get the value of p to be equals to 9, and in bracket we get the value e to the power minus of e to the power minus 0.4, and minus minus gets plus 1. So on solving this, we are getting the value which is equal to 2.97 watt approximately. So option 4 is the correct answer of this problem. Thank you.
हाय गाइस, यहाँ पे क्वेश्चन दे रखा है। इस क्वेश्चन में बोला गया है द एम्पलीट्यूड ऑफ ए डैम्प्ड ऑसिलेटर डिक्रीजेस अप टू 0.9 टाइम्स of its original magnitude 5 seconds. In another 10 seconds, it will decrease up to alpha times of original one. When the alpha is goes to, देखिए इसका हमको फॉर्मूला पता होता है a at the time t इज गोस टू कितना होता है e टू द पावर a e नॉट e टू द पावर माइनस kt। तो पहले 5 सेकंड में कितना हो रहा है 0.9 टाइम्स हो रहा है, तो 0.9 टाइम्स ऑफ a नॉट इज गोस टू a नॉट e टू द पावर माइनस 5k। ठीक है, इसको इक्वेशन नंबर 1 बोल दिया मैंने। तो देखिए यहाँ से a नॉट से a नॉट कैंसिल, तो यहाँ से e टू द पावर माइनस 5k की वैल्यू कितनी आ गई 0.9। अब बोला गया नेक्स्ट 10 सेकंड में, यानी 5 के बाद और 5 के बाद नेक्स्ट 10 यानी कि 15 में, यानी कि ये कितना हो जाता है अल्फा टाइम्स ऑफ a नॉट हो जाता है नेक्स्ट 15 सेकंड में, यानी कि a नॉट e टू द पावर माइनस ऑफ 15k। तो यहाँ से क्या आ गया e टू द पावर माइनस 15 k इंटू 15 इज टू कितना आ गया अल्फा। तो मैं इसको ऐसे लिख सकता हूँ, कुछ मैं इसको ऐसे लिख सकता हूँ, अल्फा को मैंने लिख दिया e टू द पावर माइनस 5k का होल क्यूब। ये कितना है 0.9, तो ये कितना हो गया 0.9 का होल क्यूब। तो यहाँ से कितना आ गया 0.729। सो ऑप्शन नंबर 3 is the correct answer. Thank you.
In this problem, we have given that in the figure P and Q are two coaxial conducting loops separated by some distance. When switch S is closed, a clockwise current IP as seen by E. Okay, so E is an observer. So E observes that there is a clockwise current when switch S is closed. So there is a clockwise current in the loop. Okay, so there is a clockwise current IP in the loop. Okay, and an induced current IQ1 flows in Q. Okay, so there is IQ1 current flows in Q. The switch remains closed for a long time. When switch S is open, the current IQ2 flows in Q. Then the direction of IQ1 and IQ2 as seen by ER. Okay, So first of all, when clockwise current flow in IP as observed as observed by an observer E, then there will be, due to the clockwise current, there will be the direction of magnetic field induced in the loop will be like this. Okay, so this will be the direction of magnetic field. Okay, so this is the direction of magnetic field by the loop P on loop Q. So as the current starts to flow, suddenly the magnetic field will start to flow and it will increase, and if the magnetic field across the Q loop will increase, then flux across Q will also increase, and if there is a change in flux in Q, then there will be induced current I induced will also be developed in coil Q in such a way, according to Lenz's law, that it will oppose the change in flux. So as the flux is increasing, is from right to left direction, so the current will be induced in the loop in such a way that the flux will develop in the direction from left to right. So the direction of current in this case, according to observer, will be anti-clockwise. So first of all, the current in the loop Q will be anti-clockwise. So IQ1 will be anti-clockwise as observed by E. Okay, now there is the second case. In the second case, we have given that the current initially the current is set up in the coil P, and this current is IP. Okay, now switch is open. So as the switch is open, then the direction of magnetic field, which was earlier from right to left in the coil Q, due to the current in the coil P, so this as the current reaches to 0 in the P after the switch is open, then magnetic field also starts to decrease, and if magnetic field decrease, then flux across Q will also decrease. And if flux will decrease, then the current will flow in such a way that it will try to oppose the change in flux. So the direction of induced current in this case will be clockwise. So this direction of current, so the direction of current for the second case for coil Q will be clockwise as observed by E. So that's the answer of this problem. So respectively, anti-clockwise and clockwise, that is option D, is the correct answer of this problem. Thank you.
Hello everyone, let us start with our question. In this question, what is given? A coil of wire having inductor and resistor has the conducting ring placed coaxially with it. Now the coil is connected to a battery at time t equals to 0, so that time dependent current I1 is start flowing through the coil. Now I2 is the current induced in the ring. So I2 is the current induced in the ring, and BT is the magnetic field at the axis of the coil due to IT. Now what we need to find? We need to find what is the basically product of I2 and B with respect to time, whether it would be increasing or it would be decreasing, or it does not vary with time, or it passes through a maxima. Okay, now we know that magnetic field due to current at the axis of the coil, magnetic field as a function of coil as a function of time would be equals to what? Mu naught n into I. Okay, I1 we can call, because this magnetic field is due to the current I1, so we call that B as a function of time would be equals to mu naught Ni t. So basically we are knowing that this I1 and this I2. So basically these are function of time, so we are just writing it like this. Okay, noting that we are already knowing that these are dependent on time. Okay, I1. Okay, now due to this magnetic field, okay, so there would be a EMF which would be generated by due to the change in the magnetic field. So E value would be equals to d phi over dt if we take the modulus. so it would be d phi over dt. So we can say that it would be equals to phi would be a, phi would be b into a. So a, if a is constant, so it would be a times db over dt. Okay, so we can write this value as, because mu naught and n would be constant. Okay, so we can write it as a mu naught n di1 over dt, because we know that I1 is dependent on temperature, sorry, this time. We have already stated that. Okay, now this is the value. So we can just treat this as our constant. We can say that E would be equals to some constant. Let's say this is the constant K1 and then di over dt. Now what is the value of current I2? Because current I2 is due to this induced EMF. So we say that I2 would be equals to E divided by R. Okay, so we can write here as K1 di1 over dt divided by R. So we can treat this as our another constant. We can say that it is just equals to K2 di over dt. Okay, now what would be the value of this I1? So basically it would be an LR circuit. So I1 could be written as, for an LR circuit, I1 would be equals to I naught, okay, 1 minus e to the power minus t over tau, where tau for an LR circuit is what? L divided by R. Okay, now this is the value of I1. So what would be the value of this B? So B would be equals to, because we know that B would be equals to mu naught Ni, B equals to mu naught N into I1. So we can write it as mu naught N I naught 1 minus exponential minus T over tau. Okay, we can write it like this. So we can take this result at some constant. We can just take this result at constant. So we can just write it as B equals to, we can, this is K2, we can say that it is equals to K3. Okay, 1 minus exponential minus T over tau, we can write it like this. Now what would be the value of the I2? So I2 would be just K2 times this differentiation of this value. Okay, so if we differentiate this and put into this equation, then our I2 would be, I2 would then turn out to be k times e to the power, we can just write the constant to be k4, e to the power minus t over tau. Why? Because if we see this, if we differentiate this expression, so there need not to be anything which could be differentiated. It would be equals to 0, and the it would be e to the power minus t by tau. It is written like this, and then there would be minus 1 divided by tau, and which we have termed that to be constant, because ultimately we just need to have the variation of B with t, bt with time. So if we take the product of B and I2, if we take this product, multiply these two quantities, so B value we know that it is K3 times 1 minus e to the power minus t over tau. Okay, this is the value, and I2 is K4 times e to the power minus t over tau. So again these values are constant, we can just term it as to be K5, then it would be e t to the power minus t by tau 1 minus e minus t over tau. Okay, now this is the thing which we need to, this is the final function, our B into T2. Okay, this is the thing which we need to check. Now we basically we need to check. So if t equals to 0, if we put t equals to 0, so what would be this value? So it would be equals to 1, but it would be 1 minus 1. That means our this product Bi2 would turn out to be 0. Now when t approaches to infinity, now what would be the value of Bi2? Now if t would approach to infinity, then this term would be e to the power minus infinity, and e to the power minus infinity is 0. That means at t equals to 0 and t equals to infinity, our curve is touching the axis. Okay, because these values are 0, time axis it would be touching. Now that means there would be a maxima here. So to get the maxima, what we can do, we can just differentiate this our product Bi2 with respect to time and put it equals to 0 for getting maxima or minima. For maxima, and in this case it would be maxima. So if we differentiate our this equation, so K5 won't be differentiated, so we can take K5 to be constant. Then we can differentiate our first part, so and taking it to be constant, so its value would be minus e to the power minus t over tau divided by tau, and then we need to take the bracket 1 minus e to the power minus t over tau. Okay, we have differentiated this our first part. Now we can take this part as to be constant, and we can differentiate this one. So from here the value would turn out to be, so this would be 0, and here it would be e to the power minus t over tau divided by tau. okay, and this we can put it equals to 0. So this finally, if we calculate this, then our t value would turn out to be 0.693 times tau. Okay, that means, and if we calculate our d2, d2bi2 at this value, so this value would be less than 0. That means this is the maxima. Okay, so what would be our graph look like if we plot our graph? So it would be basically like this. So initially it would be rising, okay, and after some time it would reach its maxima, and at infinity it would turn itself to be a 0. So this is the product b into I2, okay, and this is our time, and this is the time at which it reached the maxima. So which option would be the correct option for our case? And the correct option would be that it is not, every time it is not increasing with time, neither it is decreasing, does not vary with time. This is also wrong. So it passes through a maxima. So our correct option would be a D option. So hope you have understood this solution. Thank you.
Hello everyone. A vertical iron rod has a coil of wire wound over it at the bottom end. An alternating current flows in the coil. The rod goes through a conduction ring as shown in the figure. The ring can float at a certain height above the coil. In the above situation, the current is induced in the ring which interacts with the horizontal components of the magnetic field to produce an average force in upward direction. So the question has given us two statements and is asking if both of them are independently true and if statement 2 is correct explanation of statement 1. The current passing through the coil will create a magnetic field in the space, and due to this magnetic field there will be a flux linked with the ring and it will produce some EMF that will be induced EMF. Therefore, this is how the current will flow, and it will interact with the horizontal component of the magnetic field produced by this coil, and that interaction will induce a force that will be net force upwards in the direction. Thus, we can write that, and we know the direction of this thrust will be upwards because the Fleming's left-hand rule applies here. Therefore, from this explanation, we can say that statement 1 and statement 2 both are correct, and statement 2 is correct explanation of statement 1. So the answer is option A. Thank you.
हाय गाइस, यहाँ पे क्वेश्चन दिया हुआ है. इस क्वेश्चन में बोला गया है वर्टिकल iron rod has a coil of wire bounded over it over the bottom end. An alternating current flows in the coil. The rod goes through the conducting ring as shown in the figure. The ring can float at a certain height above the coil because, and this is the statement 1. Statement 2 is, in the above situation the current is situated in the ring which interacts the horizontal component of the magnetic field to produce a force acting in the upward direction. ठीक है, तो देखिए इसमें क्या होता है. जब इस कंडीशन में क्या होगा, इस कंडीशन में होगा कि ड्यू टू इंड्यूस्ड करंट इन द कॉइल द फोर्स बिटवीन टू कॉइल इज जनरेटेड. ठीक है, इन दोनों जो दोनों कॉइल है इनके बीच में क्या होगा, फोर्स जनरेट होगा. तो उससे क्या होगा, करंट इज इंड्यूस्ड इन द रिंग विच इंटरेक्ट्स द हॉरिजॉन्टल कंपोनेंट. यानी कि स्टेटमेंट 2 भी सही है और स्टेटमेंट 1 भी सही है. ठीक है, एंड वी कैन से स्टेटमेंट 1 इज द करेक्ट एक्सप्लेनेशन ऑफ स्टेटमेंट 2. सो ऑप्शन नंबर फर्स्ट इज द करेक्ट आंसर. थैंक यू.